So the blood test was developed in 1984, and it was based on finding antibodies in the serum. First, you've asked about what are the antibodies, and what are antibodies? Or antibodies are proteins of a specific structure that are made by our cells known as B lymphocytes or B cells. Each one of those little guys is programmed to make a specific type of antibody, and when he sees what he's supposed to react with, that cell will expand. It'll clonally proliferate and make a lot of these proteins to attack a foreign antigen of a particular shape that the antibody he makes fits. And when he reacts to that antigen, usually he can remove it from the circulation, helping clear the protein or the virus. That's one way of looking at it. That's why the antibodies are made. The antibodies also do other things that help the immune system. Sometimes they help kill virus-infected cells. It's another mechanism for killing beyond the killer T cells we spoke about earlier, and it's something I don't want to go into right now. So antibodies are part of our immune system, proteins made by B cells in response to foreign protein molecules, like viral proteins. Often, the presence of antibodies in your blood and in mine only reflect an exposure, not necessarily an infection that's still there. In fact, it caused confusion when we first reported the development of the blood test in 1984. People in the public health said, well, we really don't know what that means. It could mean protection, it could mean just exposure. But those of us who work with retroviruses knew it meant more, that it meant continued presence and replication of the virus. When you see good level, because we know that you don't clear retroviruses, so persistence of antibody means you're infected. It's a surrogate marker for the presence of the virus in the virus replicating, reproducing itself, active infection. The ELISA's enzyme-linked immuno-something assay, and it's based on an enzymatic reaction when these guys are complexed, when you have an interaction of antibody plus viral protein. This is a very sensitive test, but we felt it wasn't always perfectly sensitive and sometimes had too much noise. So we also wanted a backup test, the two done together, and an intelligent observer to interpret both results together. The Western blot was a research test. We actually brought it into medicine, for clinical medicine, for the first time in 1984. It was the first time that assay had ever been used for a clinical problem. So it was a research tool that wasn't set up in the blood banks and took longer to get into the blood banks. At the beginning, they only used the ELISA, and we were worried for a while because we felt certain that a backup was necessary.
You and your colleagues are known for making some pretty extraordinary comments. One of them is, you don't believe that HIV tests can test for HIV.
That's not quite true. What we say is that there is no scientific proof that the antibodies which react in these tests are caused by a retrovirus HIV.
But how can you say that when millions of people are tested every year and millions of people are told that they're positive?
Well, it's not a matter of how many people are told they're positive. It's a matter of how do you in fact sort out whether antibody reactions are specific for a particular agent or not, and that's an entirely separate issue, and that's what this is all about. That's what our first paper was all about. Our second paper was all about in 1993. Do antibody tests actually indicate HIV infection? So, how many millions of people have been tested or said to be infected is as a result of people believing that the antibodies are HIV, but the question is, are they? We don't say the antibody tests mean nothing for a start. We accept that if you're in a risk group and you have a positive antibody test, there's an increased risk that you'll become sick with perhaps an AIDS disease, and you may die from that AIDS disease. You may even have an AIDS disease currently, or you may develop one in the future. But that in itself doesn't prove that the antibodies are caused by HIV. We regard these as non-specific tests which indicate some abnormality, something going wrong in the body, which sort of indicates some propensity for people to get ill. And there are many tests like that in clinical medicine. I mean, take your temperature, for example. And the temperature is a test. People might not think of it as a test, but a temperature is a test, just like any other test. And you can measure it and plot it. And in fact, a temperature, as any mother will tell you, is an indication that something's wrong with her child. but it doesn't actually tell you precisely what it is. But it's a good test, and people have their temperatures measured all the time in hospitals. It's a good, non-specific test, and we regard antibody tests for HIV in a similar light.
Okay, in my book, I mentioned that screening tests should not be used as a definitive measure of diagnosis. And the reason for that is because screening tests are designed to be extremely sensitive to pick up all cases of HIV infection. However, in obtaining that sensitivity, we sometimes lose what we call specificity, in the sense that a test may show us a result as positive, when indeed the person may not be infected. So screening tests by themselves should not be used as a definitive measure of infection. That's why we use a screening test to pick up all the cases, but we use a confirmatory test to eliminate any false positives. There are two reasons why the Western blot is not used as the only test, or a screening and confirmatory test together. And the first reason is that it is not as sensitive as the screening assays. The screening assays are designed to be very sensitive. The Western blot is not designed to be that sensitive, and indeed, because of the nature of the way that test is produced, it does not detect very low levels of antibodies to some of those proteins, which is in contrast to the true screening test. So the nature of the test itself really doesn't allow it to be a screening test. Secondly, the test is much more costly than the screening test. So if we're screening 15 million blood units a year, which we are in the United States, and hundreds of thousands of other people are being screened, you don't want to use a $40 test for that screening. It becomes prohibitive.
How do you determine what is a positive?
Well, the tests come with positive and negative controls, and there are two positive controls. One is called a low positive control, and the second one is a high positive control. And the difference between these two controls is the intensity of the bands there. And the company who makes this test deliberately weakens the reaction so that you can mimic what actually happens when you test normal people, and you don't want to miss any bands. So the low positive control will have a low intensity band on it, whereas the high positive control will have high intensity bands, and the negative control will have absolutely no bands at all. And there's also one slight requirement in that the intensity has to be compared to the intensity of the weak positive control and the strong positive control with regards to one band. And it's going to be a little bit hard for me to explain it in just a short period of time, but the criteria used here is the GP120 band of the strong positive control compared with the GP120 band of the weak positive control. Those are the two that are going to be the determining factors. If we see any band in the patient sample that's weaker in intensity than the glycoprotein band of the GP120 of the weak positive control, it's considered as a plus-minus result, meaning we're not sure it's there, but we're not sure. However, on the other hand, if the intensity of that band in the patient sample, any of the bands, is between the intensity of the the GP120 band on the low positive control and the GP160 band on the strong positive control, it's considered as a 1+ reaction, meaning we know it's there. Now, if the reaction is much stronger than the GP120 band on the strong positive control, it's considered as a strong reaction and is graded as 2+ reaction. So that's how we grade it. So any reaction that's 1+ or above is considered as being definitely there and will count towards being present, whereas any intensity that's considered plus-minus is going to be considered as indeterminate or not sure. In the strip I'm talking about is this one. This is the negative control. You don't see any band at all across this strip, so this would be a typical negative result. Now, the low positive control I was talking about is here, and the two important bands in terms of being able to determine whether all the other bands you see in these patient samples across here are positive or negative are going to be the GP120 band here on the low positive control, LPC, and the GP120 band here on the high positive control. So any intensity that you see here in terms of bands here that is less in intensity than the GP120 band here that you see on the low positive control is considered as a plus-minus result, such as this here. We've notated here, as you can probably see, a plus-minus result, a plus-minus result. Those bands mean, for example, in this case, or let's go down here and show this band here. A plus minus for the P40 band means for this particular patient, the P40 band down here is a plus minus reaction, meaning it's not strong enough to be called a 1 plus. So any intensity in band, for example, that lies between the intensity on the GP120 band here and the intensity of the GP120 band on the high positive control is considered as a 1 plus reaction. So a typical 1 plus reaction would be, say, the P24 band for this sample, which is shown here. So this band is considered as a 1 plus reaction. And a typical 2 plus reaction would be something you would see here, which is really strong reaction. So depending on what we see, we can classify each band as being a plus minus or a plus or a plus plus or a 2 plus, that is. And then we consider the P24 band, the GP41 band, which is here, and then the GP120 or 160 band as being the most important for each one of these. So these represent each one sample, one patient sample here. So this is patient 1, patient 2, patient 3, patient 4, patient 5, and so on. So each strip represents a result from one patient.
Even if I learned many medical doctors, if they see the result and there's written even ELISA, you might have an ELISA is positive or negative, but it does not mean that the patient is HIV positive. That's a problem. And when the doctor then says, you got an ELISA positive result, the patient is already,
Right. It can be devastating.
Yeah, but because it's very, even you notice, it's a bit complicated to understand the complex diagnostic procedure and the reasons for it, why it's so. And then you have to be very careful when you talk about positive or reactive, and to explain well what you mean by indeterminate.
There are in the whole HIV/AIDS kind of discussion, public and the scientific discussion, there are a number of discrepancies and a number of things you discover when you're working in the field. And one aspect is, or one question is, are there people who turn negative once they have been positive? And the general perception is, no, that's not happening. And that's definitely wrong. And it happens more frequently in Africa, but it also happens in developed countries like in Europe. And I personally know a nurse who has been positive, HIV positive, a few months after a hepatitis B vaccination. And 3 years later, she turned negative. And she had no risk factor whatsoever. She was living in the countries, in a small city in Austria, having 2 children, no risk factor whatsoever, beside this hepatitis B vaccination. And she didn't get a clear answer, explanation why she turned negative after 3 years. And this is very disturbing. Not the fact that there are contradictions happening, but what is disturbing that there is a tendency to pretend these things don't happen. From a scientific point of view, you would expect the exact opposite behavior. If there is some event, something happen against your expectation, you would be very excited and study this event, because that's where you can learn more about what the subject you are studying. But this nurse, instead of being studied, she just was turned away and asked to never come again back to the central hospital in Austria. I try to always verify whatever I do and whatever I say in my profession. I think we owe this to our patients, to verify whatever we do and whatever we say. Otherwise, we can't keep up the highest standard in medicine. So the other way, I went to a lab and asked for the package insert, the product information of the ELISA test which they used. And I got it back and I went through it, and I was very surprised to find a statement by the producer that in a study, 40% of those people who had influenza vaccination turned out with a positive ELISA test. Now, if you keep in mind that influenza vaccination is quite widespread in a number of countries in the world, this is a serious risk of false positive test results. Now, we are aware that all biological tests are not 100% accurate, but we should exert some transparency, and especially when there is such a high risk of false positive results in such a common event like influenza vaccination. I think we should be aware and make people aware that this can happen. I think we owe this transparency and honesty to our patients.
PCR testing, as with any test, has its limitations, and there are false positives that occur with all tests. We have them with antibody tests. We even have false positive Western blots that have been documented. RNA testing has been perfected very much over the last several years, and the degree of false positives that we were having years ago, we don't have anymore. However, they do still occur, and what most good laboratories will do, whether it's an antibody test or a PCR test, is if it's a first-time positive on a patient, they will put a note in the report that says, we recommend you confirming all first-time positives. And that's because these tests do periodically have false positives. And in most cases, those false positives are due to technical error. And we all make technical errors, we all make errors, we will always make errors. We have as many foolproof mechanisms in the labs as we can, but periodically those errors do get out. And so we all have to be very vigilant and remain that way. For diagnostic purposes, if it's PCR positive and antibody negative, then yes, there's generally a follow-up. You would like to wait to make absolutely sure that that person does seroconvert for antibody within several weeks.
There's a whole range of conditions that can cause you to test positive, to have raised levels of the antibodies that the test looks for. Big range of conditions. Some more than 60 have been documented in the official medical literature, and there are probably more than that. Many, many different things, like you can test positive after a bout of flu or a series of flu jabs. You can test positive in pregnancy, especially repeated pregnancy. You can test positive if you've been exposed to the tuberculosis microbe, or not just if you've got TB, but if you've a friend, a close contact who's got TB. There's a big range of these conditions that can cause you to test positive that have nothing to do with some new virus, but which is, and the fact that the level of background raised levels of these antibodies, this million, sort of 1 in 250 or so people, 1 in 300 in the States, who are said to have these raised levels of these antibodies, that doesn't tell us anything, in fact, about who is infected with some deadly new disease. It just tells us that there's a certain level of background ill health which is picked up by this non-specific test.
When they say the tests are 99.999% accurate, they're defining those terms themselves. They don't say accurate, by the way, they say sensitive. Sensitive is like if you're a very sensitive kid in school, you get your feelings hurt a lot. A very sensitive test picks up everything. These tests are incredibly sensitive. They react with just about everything. The tests are either strongly reactive or weakly reactive. There's no such thing as positive and negative. You don't get a plus or a minus on the test. You get a color that's read by a machine, spectrophotometer, and called a spectrophotometer, and you look at the color, and if that color is above a certain point that's been designated by the company that manufactures the machine or the test, you then decide that that's more probabilistically positive. But then you have to interpret it according to the person you tested. And that's all important.
Gallo created the ELISA style test and marketed that as a product that could tell you that you were at risk of AIDS or that you were infected with AIDS. The big mistake that happened there was that the test was never validated as demonstrating the presence of virus. If you're going to validate a diagnostic test, you need to be able to show, unless in exceptional circumstances you might have a hunch that you go another way, but then you'd have to be extremely cautious about what you were going to do with that. It might just be a pointer in a particular direction. But if you're going to tell someone that they are infected with a lethal virus that is going to take your life, is going to cause this collapse of your immune system, you need to be extremely careful what you're doing with that. Unfortunately, that care was not taken. The purpose of presenting the world with an HIV test, as it came to be called, was twofold, as I would understand it. One was that it would be there to protect blood supplies, the safety of blood supplies. And in fact, the HIV test, as marketed by Gallo and associates, was valuable for that purpose, because the test does discriminate blood that has been donated by people whose immune systems may have been activated in such a way that they have raised levels of these antibodies that the test looks for. And raised levels of those antibodies can be associated with ill health. There's no question of that. That's how the test was actually set up. But what the test does not do, which was also claimed for it, unfortunately, by Gallo and others, is act as a diagnostic for the presence of HIV in individuals or in communities. It's not fit for doing that. And yet it came to be seen as something that would be, if you tested positive, then it meant you were infected, and therefore you should be a candidate for all sorts of changed aspects in your life, and ultimately that you would become a candidate for taking antiviral drugs and all the rest.
I think history will show that the Defense Department really had one of the most sophisticated and accurate serological programs to support HIV diagnosis ever. And it sort of built on the technology that was developed with NIH, Gallo's group, and others on building the initial ELISA. But then if we had to apply a confirmatory test, so we brought in these Western blots. There were no licensed Western blots at the time. And then we had to figure out what the right algorithms were. We actually had to figure out ways to make sure that people just didn't confuse the blood, so your blood wasn't his blood. So we actually required very sophisticated criteria to be reactive in the initial test, but we didn't confirm the diagnosis of HIV infection until the patient came back a second time, had a second sample confirmed again, because actually in many of the populations that we were evaluating for HIV infection, the actual real prevalence of infection was less than 1 in 1,000. So if you made a mistake 1 in 100, that would be a disaster. So we did develop all of that technology, and really in 1985, really 6 months after the blood supply was using the technology for screening blood, the Defense Department began to use it as part of medical evaluation of individuals. And I think it's a matter of public record that the Defense Department did a superb job of it, published a number of publications, including the New England Journal, showing that this could be done very accurately.
It's hard to state how accurate your test is when it's not for diagnosing infection with HIV. Abbott Laboratories got around this problem simply by stating that if one assumes that clinical AIDS patients are HIV positive and that blood donors are HIV negative, then their test performance can be evaluated on this assumption. But they clearly state that there is no standard for determining the presence or absence of antibodies in a sample. So the rapid test kits are evaluated by comparison to these other tests. And that's how their accuracies, known as sensitivity and specificity, are determined. Not against a gold standard, but rather against somebody else's test.
The antibody test was a stopgap measure, I think a very faulty one, to try to get a hold of what might have been happening in the gay community with guys getting sick. It was mostly to, well, its initial purpose was to examine the donated blood supply. And it was run through this sort of sieve, which was this antibody test. And this antibody test was culled from all these proteins from these laboratory experiments. You know, at that point, by the way, the quotes are outrageous. It was known that 2 to 98 or 99% of the population, depending on the sample, depending on the test, would be reactive with the test. Somewhere between 2 and 98%. That was it. That's just from the literature. They say it's better now. I think they just target risk groups more effectively now.
Well, the package insert of an HIV test is kind of the product information which comes along with an HIV test. It explains what the test is about. It explains how it's working for the technician, but also it explains the limitations, which every test has. Every test has limitations. Even the best test has limitations. And I think it is important for not only for healthcare professionals to read and be aware of the limitations of whatever they do, whether it be a diagnostic intervention or a treatment, but it's also important for patients to be aware of the limitations of what we doctors and other people in the healthcare system perform.
So it's a very important technology, actually. It allows you to take and determine, does somebody have antibody against all the different pieces of the virus. Because if you're exposed to this virus, you're likely to have antibody to all the different pieces. And so I can determine with really enormous accuracy. I don't know if you've ever seen a Western blot, but I could show you one. But they're very, it's just, once you see it, it's really pretty straightforward. So the screening tests were just developed to be highly able to pick up people that may be infected, may not be infected, and then the confirmatory tests were made to be very, very accurate. And so the Western blot, as I said, is a way to separate the virus into its building blocks and ask the question, does the patient have antibody against all the building blocks? And each virus would have a different, if you took a virus and broke it up, it may have different size pieces. And the AIDS virus has a very distinct molecular weight proteins that you now can see, and you can react to it that way.
After 4 weeks, will the body have developed antibodies to all the components of the virus?
In general, they do. After about 4 weeks, the antibody responses are pretty robust, and they come up to different components. But shortly after that 4-week period, within another couple weeks, almost everybody responds with a full antibody profile against all the viral components. Actually, interpreting Western blot results is not that difficult, although experience does help a lot. And of course, the most important thing is that when you are trained in reading these, you are alerted to some of the, again, unusual types of things that happen. I'm sure we could train a lot of people to read a full profile and say, look, if these 9 bands are there, here's the guide. If these 9 bands are there, you call it positive. That can be done very easily. But what we find is some cases where things are not quite that clear-cut, where we have something that looks like a negative Western blot, but there's a little shadow someplace. And somebody not well schooled may not call that little shadow or even see it or not recognize it, and inappropriately call that pattern as negative, when in truth it's not negative, it's indeterminate, because it has something. In other cases, a profile that is not positive, but suggestive of. In other words, it's got some bands, but not all that's needed. Maybe 2 out of 3 that are required. It has only 2. And instead of just calling that indeterminate and leaving it that and asking for follow-up, perhaps understanding what a different virus variant might produce. For example, HIV-2, which is a little different type of HIV virus, or the HIV-1 group O's or group N's. There's some strange types of little different HIV viruses that produce different profiles on Western blot. And if you're really educated on that, you may see the 2 bands and say, well, it's not positive for one, but maybe I ought to do a different test for HIV-2, or maybe I should send it to a specialty laboratory to see if they can do a group O test, in which case it could come out positive. So again, if you're familiar with these types of things, then you can follow up and you can do perhaps some different studies to try to figure out if that's really truly a positive person or not. And then we also have the problem of people that are in the process of what we call seroconverting, where I told you that in 3 to 4 weeks antibodies produced. Well, suppose you test a person at 3.5 weeks and some antibodies are produced, but not all of them. So you get a partial profile by Western blot. And if you recognize that and you know which antibodies come up early, you can make an educated suggestion perhaps that this appears to be a person undergoing seroconversion and that we must test them in another few weeks or a month to see whether that's progressed to a full profile. So again, you get incomplete patterns, you get unusual patterns, you get suggestive patterns, you get patterns that could be called negative or could be called indeterminate depending on who's reading them. Is a band a 1+ or a plus-minus? You know, if it's a 1+, then the person's positive. If it's a maybe plus-minus, the person's indeterminate. You may call that different than I do. So there's some subjectivity in these readings of these. So all these things come into account, and the experience helps a lot to interpret these correctly or to at least add the caution to follow up.
Well, HIV infection is diagnosed with rather now routine laboratory tests, which, for which there are criteria for diagnosis established by the manufacturer, FDA. I mean, 15 years ago it was different, but I mean, it's not.
So CDC doesn't regulate that anymore?
No. CDC doesn't regulate anything.
Okay.
It's FDA does.
Centers, that's the recommendation for Centers of Disease Control. Okay, to have at least one ENF and P24. That's what we are using. What's also the Huh?
Over the years, there was a greater standardization of the tests, in that certain proteins were specifically singled out as being representative of HIV, and more tests used those specific proteins in this looking for antibodies to the antigens of the virus, purported virus. But if you have not shown that those more specific proteins, those proteins that you all agree on, but if you haven't actually shown that they truly belong to this purported virus, then the fact that you get greater agreement amongst yourselves about the results of your testing still doesn't mean that you're diagnosing the presence of this virus. It's just a greater level of agreement on a kind of virtual virus. Because of the different criteria that apply in different countries, you can be considered, you can test HIV positive in one country and be given an AIDS diagnosis as a result of that, whereas in another country you won't test HIV positive and you won't be given an AIDS diagnosis, even though the blood sample might have been the same and the interpretation of it the same, but because one country considers 2 proteins to be diagnostic and another one requires 3, for example, then you travel from country requiring 3 to where you're an AIDS patient and HIV infected, and go to country, B, where only 2. Sorry, I've got that the wrong way around. You might say what could happen would be that if in country A, the fact that you have two proteins that react with the Western blot test, and so you will then be considered to be, in certain countries, you would be considered to be HIV positive, and maybe also an AIDS patient if you've got indicator illnesses. You travel to another country that requires 3 proteins to react instead of 2, and you've only got 2, you won't be HIV positive and you won't be an AIDS patient. You'll just have whatever illness you might have had, such as TB or leprosy or some chronic intestinal infection, whatever one of the multitude of different diseases that can cause this activation of the immune system you're actually suffering from.
The one thing you said was, you said it depends on the manufacturer. Is there different criteria for what might be a positive?
Yeah, there are different criteria from the manufacturer. Thank you for the word. And also there are guidelines from the WHO and UNAIDS how to, first of all, WHO, how to evaluate. And depending on the studies, you use the one or the other criterion.
Which one do you guys use?
We say on the basis of 2 bands, which one N and one GAG, it's positive.
So 2 bands need to be present for a positive?
Yeah.
Okay.
And the WHO criterion is, if I'm right, is 3 bands.
3 bands, so it's more...
So it's 2, and then you have the second envelope present in general.
So theirs is more strict?
Yeah.
Okay.
If you read the literature, or if you read the packet inserts the laboratory, the manufacturers of the tests provide, they actually tell you the different criteria, and around the world there are at least 10 different criteria for diagnosing a positive Western blot, and they're all different. They're so different that you can be positive in one laboratory or institution or country and not be positive if you go somewhere else on the same specimen. So these tests are not standardised, but it's essential to standardise tests, because if you're tested in Africa for HIV, then you want to know whether you've got HIV. You don't actually, and if you're tested in America, you want to know if you've got HIV. So the test should be telling you the same thing. So it's ludicrous that you can be positive in one country and not positive in another. I mean, it would imply that immigration could alter your positivity status. In Africa, the criteria are yet again different from most other institutions, from most other jurisdictions, and they include 2 glycoprotein bands, and any other bands are actually optional. You can have them or not have them. Which means now in Australia, using our National Reference Laboratory standards, you need 1 glycoprotein band and 3 other bands from the other possible proteins in the strip. And so theoretically, it's possible that someone could be positive in Australia with 1 glycoprotein band and go to Africa and not be positive because they haven't got 2 glycoprotein bands. In Australia, we need 1 glycoprotein band and 3 other bands. In Africa, you need 2 glycoprotein bands and all the other bands are optional. So if an African had, for example, 2 glycoprotein bands and no other bands and came to Australia, he would not be positive. If he had 2 other bands, he would still not be positive because you need 3 other bands in Australia. On the other hand, a person positive in Australia with 1 glycoprotein band and 3 other bands would not be positive in Africa because you need 2 glycoprotein bands in Africa. Well, Myron Essex is a United States very well known, highly respected HIV researcher who did a study in 1994, I think. Sorry, in the mid-90s, I'm not sure of the exact date. Who discovered that patients with leprosy have antibody tests who are not HIV infected have many reactivities to the proteins in the Western blot, HIV Western blot kit, Western blot test. So much so, and the other important thing is that, in fact, it was about 80% of the patients and 60% of their contacts, people who didn't actually have leprosy, who'd been in contact with patients with leprosy. And the other important thing is that the organism which causes leprosy is closely antigenically related to the organism that causes tuberculosis. They, in fact, cause the same antibodies to develop. And so what Essex showed was that the antibodies that develop in response to these organisms react with the HIV proteins. In fact, he had some Western blot strips in his paper which showed many, I think there was about 14 or so Western blot strips that were considered to be not positive in Africa because they lacked 2 glycoprotein bands, but if you study them from the point of view of the Australian criteria, they all would have been positive. And in fact, Essex warned, in his paper, Essex said that HIV ELISA and Western blot may not be sufficient to diagnose HIV infection in areas where TB and where mycobacterial diseases such as TB are endemic, and that is Africa. As I said, 80% of the leprosy patients and 60% of their contacts had reactivity in the HIV Western blot, the HIV Western blot. And in the Western blots that were published in this paper, there are 3 which are positive. One was a control serum, known to be positive, just to make sure the test is working, operational. And 2 were leprosy patients that were infected with HIV on the basis they had 2 glycoprotein bands. But there were 16 other strips. And arguably, when you sit down with the rule book for Australia and look at the Western blots, 14 of these would be positive in Australia, not positive in Africa, positive in Australia, but we have the most stringent criteria in the world. Now, typically, people who are HIV positive and people who have AIDS have high levels of gamma globulins, high levels of antibodies in general, of all sorts. And in fact, it's known that you can predict, there's a high correlation between the level of antibodies and the probability that you'll test positive. And we can explain this on the basis that, as we said before, the more antibodies you have, the more opportunities there are for one of them or several of them to react with any antigen that you offer it. And so one would expect people who have higher levels of antibodies to have positive tests. In fact, there's some very good data that this happens, and one of the best pieces of data comes from a never repeated and never followed up study done in 1990, reported in the New England Journal of Medicine, in 26 hospitals, where they tested blood specimens from approximately 90,000 patients who none of whom had a ghost of a chance of having an AIDS disease or being in an AIDS risk group. And they found that in some hospitals up to 22% of men and 8% of women in the AIDS age group, that is 25 to 44, were HIV positive on the ELISA and Western blot. Yet these people were not at risk of AIDS at all. And surely if one needs, if anything, we must ought to convince people that these tests are picking up something else. And if the illnesses that these people had, because they must have had illnesses because they were in hospital or they were either in hospital or attending hospital, can produce positive tests, why can't the same factors operate in people who don't have these diseases, people in AIDS patients? AIDS patients don't just get AIDS. They get all the other diseases as well. And why can't the same thing apply to Africa, where the only difference is that the people in Africa aren't in hospital, because there are not that many hospitals in Africa. It's easy to imagine that the same people who are, well, at least some of the people with the same degree of illness, are actually walking the streets. So talking about false positives as defined by the AIDS experts, okay, forget the Perth group and all the things that we say. If you read the textbooks and the journals, the AIDS experts say that hypergammaglobulinemia can lead to false positive tests. That's one thing. Now, we know that people who are HIV positive and who have AIDS have high levels of gamma globulins. So why aren't they false positives? How do they know? They're not. And in fact, the same sort of thing happens in mice. If you inject mice with the cell wall of E. coli, which is a very common germ in the bowel, they develop antibodies that react with the GP120 and GP41 proteins, the 2 glycoproteins. And if you inject mice with lymphocytes from other mice, they develop antibodies to P120 and P24 HIV proteins. But there's no HIV in this picture. This kind of thing has been recorded. There's at least one case in the literature where a man was given repeatedly injections, a small amount of Rh negative serum from people who were deemed not to be HIV infected. And after the first injection, he developed some Western blot bands. And after the third injection, he had sufficient bands to make him HIV positive, just about on all criteria, from all institutions. And yet he wasn't HIV infected. This was written up in the literature about 15 years ago. There is a paper published in 1990 by Strandstrom from Davis University in California, where they tested 144 dogs and found that 72 of them had one or more bands on the Western blot. Unfortunately, they didn't actually say what each dog's Western blot was. But if you were to use the pre-1987 Western blot criteria, there were certainly dogs that had a GP41 band or a P24 band, something like 23 and 40% respectively. So on those criteria, yes, they would be HIV positive. They certainly produce antibodies that react with the antigens in the Western blot test, although dogs don't get HIV or AIDS. If the proteins can react non-specifically in the ELISA, and the HIV experts accept that they do, why can't they react non-specifically in the Western blot? How do they know that the patterns that they get in the Western blot are actually caused by genuine HIV antibodies on some occasions, and on other occasions by non-genuine HIV antibodies? How do they know that? The only way that you can tell, I mean, an antibody doesn't care whether it's reacting with a protein in an ELISA or on a Western blot. It can't tell the difference. Antibodies don't have intelligence. Antibodies just react with the antigens because they can. That's in their nature. Just as lemon juice reacts with milk proteins and vinegar reacts with milk proteins because it can. So if you postulate that certain patterns of Western blot reactivity prove infection because the antibodies are genuine, you have to prove it, still have to prove it for each of those patterns using a gold standard. And there are no such data.
What do we mean by polyspecific antibodies? Well, each B cell in the body that makes antibodies is monospecific or unispecific, if you like. It only makes one kind of antibody. But because there are millions of B cells in the body and several thousand of them will respond to a particular infection, whether it's the common cold or HIV, many thousand B cells will make antibodies to slightly different shapes or parts of the virus at any one time. And that means they are polyspecific, or I would say multi-specific.
Have you ever had any conflict with Dr. Constantine or another lab technician where you interpreted a test one way and they interpreted it a different way?
Well, to be quite honest with you, there are always going to be one of those few cases where you're really not sure. For instance, a patient might have only 2 bands present across the strip, just 2 bands. And these might be the GP 120 band and say a P24 band. Both of these bands are the critical bands that I told you about earlier, 2 out of the 3. If these are present, then that's considered a positive. Now, if I grade that P24 band as a plus minus, and Dr. Constantine, for instance, grades that as a plus minus, that could make the difference between an indeterminate result and a positive result. It would be a positive result if the P24 band is considered as being present, whereas it would be an indeterminate result if it's considered to be not sure.
The indirect fluorescent assay, which is another confirmatory test, is equivalent to the Western blot in the sense of being able to confirm people that are HIV positive. It has one added advantage also, and that is in the case where a Western blot perhaps is indeterminate, the indirect fluorescent antibody test can be used to resolve that. So if a Western blot's indeterminate and the IFA is positive, then that's definitive, the patient is infected. So it adds that. However, the test is a little bit more difficult to interpret and is very subjective, as is the Western blot. But it requires some added expertise in reading some of these results and making sure that you interpret the results correctly, and requires an expensive fluorescent microscope. However, it seems that it's more popular in Europe, and it's hard to say why. The reason is some of these tests are already in use in laboratories, and so they're easy to modify to be used for HIV. And in the United States, although we have the fluorescent techniques, it seems the Western blot gained popularity early on, and people don't want to quite let go of it.
Yeah, I see these numbers in the literature, And I also see them in the newspaper, these numbers about tests being 99.99% accurate. I have no idea what this means. And I've been studying this for years, and I've also developed HIV tests. I have patents on HIV tests. I think these numbers come from a couple different ideologies, if you will. They're certainly not numbers that say my test determines the presence or absence of HIV in a sample with 99.99% accuracy. Many years ago, a study was published by Burke et al. And this study was trying to evaluate the accuracy of the HIV test in a population of Army recruits. When persons come in, sign up for the armed forces, they are required to have an HIV test. The strategy was to test these people on many different tests and determine the accuracy based on the concordance between these various tests, which is really not a valid a valid methodology. I think I'm getting too technical here. Well, the outcome was that many of the tests gave the same answer, and therefore these researchers assumed that because 5 different or 4 different tests gave the same answer, that this was correlated with accuracy. However, none of these tests were approved for diagnosing HIV. So I do not understand the concept or the ideology or the thinking that if you take 5 tests, none of which are approved for diagnosing HIV, and they all give the same answer, that means that they're 100% accurate for diagnosing HIV. In fact, many of the comparisons or statements of accuracy that we see in the scientific literature are nothing else, or many of the statements that we see of accuracy in the scientific literature are nothing more than a comparison of one test to another test, okay, or one test combination to another combinations of tests. So as a researcher, you can set up an algorithm or a combination of tests that you declare is your gold standard or that represents 100% accuracy. And then based on your test, you can judge other people's tests, or vice versa. You can assume that somebody else's test is 100% accuracy. You can assume that somebody else's test is 100% accurate, and then you can judge your test kit against that test kit based on that assumption. So if my test says what your test says, so if my test has the same result as your test does 99.9% of the time, then I can declare that my test is 99.9% accurate. But we should always keep in mind that your test was not approved for diagnosing infection with HIV in the first place.
If anything appears that's not supposed to be there, if there's what's called an errant band of protein that shows up that's not supposed to be there, then it becomes an indeterminate, because you can't call it negative, you can't call it positive. That's when they do a little, it'll come back to me to do a little bit further testing. You know, is that person, did I get a complete risk assessment on them, things like that. And then usually we'll follow up a month to 2 months later.
An HIV test is not a black and white answer. It's always interpreted at a laboratory by a human being, and their interpretation can change based on your health history or life history. I'll give you one quick example. A woman in a hospital in Canada about to deliver a baby was HIV tested. Her results came back indeterminate because her medical records showed that she had had previously a history of IV drug use. They bumped up her indeterminate status to positive. As a result, she gave up her baby for adoption, and that same day had an operation so she could never have children again. Years later, during a drug trial, she repeatedly tested negative. She was never positive. That's what interpretation is.
The manufacturers don't clearly state how their test should be used as an aid in the diagnosis of HIV infection. However, Part of this paradox can be solved by looking back in time to 1987, when the Center for Disease Control declared that an antibody test was sufficient to diagnose infection with HIV. So this notion that antibodies equal HIV is not a scientific discovery, but rather it is something that the Centers for Disease Control simply declared in 1987. It's also interesting that 1987 was also the year that AZT was approved by the FDA. However, this drug was approved for treating people that were infected with HIV. Unfortunately, there was not a test on the market for diagnosing infection with HIV. In fact, there still is no test on the market for diagnosing infection with HIV.
1985, the blood test was released for commercial use.
Yes.
Did the CDC go back and test all the people they had diagnosed with AIDS up until that point?
No, we did not. The reason was we'd used all the bloods up testing for everything else. We'd used the bloods up. We'd done tests for toxo and herpes and cryptococcus and cyclosporin and nitrite levels. There was no blood left to test in that original population.
Okay.
So no, we did not go back and test those.
Rapid testing was introduced actually in the late 1980s, perhaps around 1988 with the first rapid HIV test. And over the next several years, more manufacturers started to produce them. And by 1992 or so, we had a good variety of rapid tests. I would say at least 4 or 5 from major manufacturers. At that time, the companies, the smaller companies weren't really doing it, and people weren't making them in their garages at the time. So you started with the bigger companies. Around that same time, 1992 to 1994, is when people started to see the value of these things in developing countries where there wasn't stable electricity or laboratory expertise to be able to do HIV testing. And they were introduced into Africa, and there were some reports about how they worked and so forth. And generally those reports by the mid-1990s were very good reports, and people knew that rapid tests were here to stay for developing countries. One of the reasons these rapid test strategies and algorithms are so useful, and particularly in developing countries, not only are they simple and can be performed in these laboratories that may not have stable electricity and all, but they also have the ability to save a lot in money. And until recently, it was very difficult to spend $5 on an HIV test in a country, in a developing country. And so the Western blots that the developed world used to confirm are about $40 per test, and sometimes more expensive. And so if you tried to confirm an infection in a country in Africa, let's say, you couldn't spend $40 to confirm each one of the tests that you needed to confirm. It was too much money, and nobody had that money. And so by using these alternative algorithms, 2 screening tests, each one that might cost $1 each, and you have $2 to confirm a result instead of $41 with a screening and a confirmatory test. The World Health Organization has actually had strategies using combinations of rapid tests or combinations of rapid and ELISA tests that would give you the same result but at a much reduced cost. And these have been available way back in around 1993. They were introduced, and WHO still stands by those, although they are constantly modifying them slightly. But again, the purpose here is to be able to do simpler technologies but arrive at the same results. And you can do that, it's been shown, you can do that if you carefully select which test to use in what sequence. But very importantly, you must evaluate those types of testing strategies and algorithms within the country in which you want to use them. We had tests, rapid tests, that would work fine in Egypt but didn't work very well in Djibouti. And the reasons for that is because Djibouti had some other types of infections that would interfere with these. Malaria was very prevalent in Djibouti, and that would interfere interferes with all serologic tests, where in Egypt they don't have malaria. Similarly, there's other countries that have a lot of parasitic infections that produce a hypergammaglobulinemia or a high protein in the blood that again will interfere with tests in that country. So you have to carefully select the tests you use in the venue or in the country of where you plan on using it, and you have to validate that that test or that sequence of tests you're using does work in that country. Do you want me to say a couple words about the CLIA waiver at this point? Would be a good time to do it.
Yes, please.
Okay. In addition, rapid tests offer something what we call CLIA waiver. And the CLIA is the Clinical Improvement Act, which is you know, a government mandated way of doing testing. Most clinical laboratories and hospitals in the United States have to be certified to be able to do diagnostic testing. And that's all regulated by the government. Now, we have the ability to get a waiver for some of that certification and to be able to do simple tests in a non-certified laboratory. And this is what we call a CLIA-waived laboratory. And in this case, you have to follow certain regulations, but they're nowhere near as stringent as the regulations required in a hospital laboratory or a larger testing facility. And these rapid HIV tests now, some of them that are FDA approved, have this CLIA-waived status, which means that they can be done by nurses and people that are trained pretty much on the spot. Some sort of a healthcare worker can be trained to do these rapid tests. So again, you have a much larger variety of venues where these tests can be used. Mobile vans, for example, where you don't have a whole laboratory or certified lab set up. You can meet certain qualifications and be able to do testing in a mobile van outside of a supermarket, for example. This offers an immense ability to get more people tested by taking the tests out to them rather than having to schedule people to come into a clinic and find transportation and somebody to watch their kids while they go to the clinic to get tested. Now we can take the test to them. So it's an enormous advance to be able to do this type of testing out as we go into the periphery. The concept of CLIA waiver was because they were generally types of tests that did not have a huge impact, like glucose testing. Okay, glucose testing, yeah, if you make a mistake, the patient doesn't necessarily die from it. Although I guess, you know, if they put too much insulin in them. But that was the general concept. You know, it wasn't like a potassium level that, you know, getting a wrong result would kill the patient. And so I think that was why the FDA originally considered HIV testing as to meet part of that, because they felt it was a screening mechanism that wasn't really a life-threatening type of result. And that, you know, if you got a false negative, hopefully the person would still get tested somewhere. False positive, they'd have to go back for a confirmatory test. And in HIV testing, these were allowed to be CLIA waived because, again, they feel that the patients, if they have a positive result, even if it was performed incorrectly, that would have to be followed up with a confirmatory test, in which case they would detect an error if it had occurred. And false negatives, which are not very common to happen with these tests, also is not a life and death situation at that time. Hopefully that person is high risk and would be screened again in due time and picked up at that time. I think that was the impetus for trying to get these tests waived. The most important thing is to have more people tested, because the more you test, the more positives you find, and then you can save lives that way. So it's a risk benefit. The risk is that, well, they're not quite as well trained people maybe, and there might be a chance of an error, but the benefit is great because we can save a lot of lives by identifying people that are infected. But this is actually, and this is an interesting concept, because the FDA is now considering of whether rapid tests should be able to be sold over the counter, OTC, over the counter sales, like pregnancy tests. And there's a controversy that the FDA has been listening to both sides. The people and the companies that make these tests say, look, we want these tests over the counter, we'll get more people tested. And that is the strongest advantage of having over-the-test counters, is that you will indeed get more people tested, and you will save lives. However, there's the other side of the argument, which deals with things, the disadvantages of having something like that. One notable disadvantage would be misuse of the tests. Somebody can force their spouse or partner to take a test against their will. You know, HIV tests, we have to have consent to the person's consent to do testing. Well, in the privacy of a home, someone can be forced to take a test, especially if it's a simple test such as a orally collected sample. So we have misuse or abuse of these tests, which is a legal matter. We also have the concern about the worry wells, the people that go out one night and have an event, and then they run out to the store and they buy rapid tests all week long, not understanding that it takes that 3 to 4 weeks to have antibody. And so you have a lot of wasted money, and these may be people that need that money. We estimate that if a over-the-counter test, rapid test, were approved, it would probably cost about $40 a test. And so if you have poor people worried about being HIV infected and using their family food money for buying HIV tests all week, perhaps inappropriately because they won't work that fast, that's a concern. It's an economic concern and so forth, a family concern.
Why $40? That's the same price as a Western blot when it's only 97 cents to manufacture.
Sure, that's a good point, and it's exactly right. In fact, to manufacture these tests is probably less than 90 cents. It's probably about 10 or 15 cents to actually put one of these tests together. The problem is I understand from manufacturers that the largest cost of these tests is in putting them in a box with the printing and the labeling and you know, the packaging, and to make these things look nice, and of course you have the advertising. If it's over the counter, there's going to be things on TV, which is $1 million a minute or so. So when you add all these things together, of a company putting these things in single packages with package inserts and advertising and pretty boxes and whatever, you can see where the cost goes up enormously. And then there's the profit margin, of course. The company has to make a profit to pay people, and they also have to pay for the research they did in developing the test. We have the same problem with drug companies and making drugs and charging a certain amount of money. And you know, some of it's justified. The public doesn't understand that what these companies invest, you know, they can invest a huge amount of money to develop to end up with one test that works. You know, it's not as simple as just all of a sudden it works. I mean, it may take years and a lot of resources, and so that has to be paid back to the company. Companies look at profits over a certain period of time. So I'm not justifying the cost of anything. I'm just saying when you add all these things up, and especially if there's no competition, the prices become very high on the market. And this is what we estimate it would probably cost.
This is an HIV test. It says in its own material that it means nothing. It means we're going to test you, and then we'll interpret the test according to what we consider your clinical disposition. And if we think that maybe you're at risk, and by the way, the great thing about AIDS is you don't have to be sick when we say you're sick. You don't have to be sick for 10 years. You don't have to be sick for 20 years. In fact, we don't know when you'll get sick or if you will, but you have HIV and then you'll have AIDS and eventually you'll die, and we now govern your sex life and everything else. If you're in that weakly reactive group though, but they think that really you're probably positive, they will retest you. This is from the UK guidelines for testing in 2003. In the UK, they don't, by the way, if you test weakly reactive, but they think you're at risk, they'll want you to retest again. And in this country, they usually say, do it after 6 months. In the UK, they don't even wait 6 months. If you test negative, that is weakly reactive, but are considered to be at risk, that is, you had sex or did drugs and we think that really you should be HIV positive, shouldn't you? Then clearly, quote, clearly waiting for 6 months to test is untenable. We would suggest testing using a sensitive, that is highly reactive, 4th or 3rd generation screening test immediately after the exposure, and then at 1 to 2 months, at 3 to 4 months, and at 6 months. What's the exposure? Whatever they think it was. I had sex, but I'm not testing positive. Okay, we want you to test again. Now they'll say that it takes a certain amount of time to develop the antibodies. It doesn't matter to them how much time it takes. They want, this is too much information.
How come you don't use rapid tests for standard diagnostics?
Because first of all, the sensitivity and specificity is still less than the released tests, which are released in Germany to be applied for testing, for diagnostic testing. And all the, I do not know the word for Fachgesellschaft. Do you know it? No. Yeah. So let's a little bit talk about it. So you have several professional organizations who decide as an expert committee on guidelines how to do things. Mm-hmm. And though none of these responsible societies recommended home testing for scientific reasons.
Okay.
And there are even, I know that home tests or rapid tests are used in African countries, for example. Mm-hmm. And there you have the advantage. They are used because there's no need for storage in the refrigerator. They can be used at room temperature. And as I told before, if you have a high prevalence of HIV infections, you have less risk to pick up false positives.
Okay.
Which might happen in countries like Germany with prevalence below 1%.